Hey everyone, today in this video we're going to discuss the concept of star schema and how it can be used in a daily life scenarios like the university database. So we'll explore how and why this structure is effective and break down each part of the schema of the university database. So university database with using a star scheme design. So this is my team. My team members are Aditya and myself Manohar. This is Ganesh and Akshit and Pawan. So before dwelling upon completely upon our project, let's have an overview. Like the university database is nothing but it is simply and used to track the enrollments, of course, the courses, faculty assignments, and departments. Let's say that even LPU has an university database like which tracks all the students enrolls, like who is enrolling into a particular course or who is taking off from a course, and what the courses each student is having, and what faculty is assigned to the each course and the assignments, and what department do the faculty you know they correspond to. So like we are using a star schema model for this, for the university database, because if it is efficient query, uh, it can optimize the complex queries and support the insightful analysis. uh, so what is a star schema? So, like to completely understand the university database using the star schema, let's start with what is a star schema. So, like we all heard about the data warehouse design structure, right? So, it plays a star schema plays a crucial role in the data warehouse design structure in designing a warehouse. So like it organizes the data into a central fact, like by surrounded by the dimension tables. Like it is basically in the shape of a star, so hence the name star schema. So if you, it has a fact table in the middle, which is surrounded by the corresponding dimension tables. So it is widely used in the analytical system because it streamlines the data retrieval and supports quick data analysis, like like a quick query analysis. So the components of this star schema are nothing but fact table and dimension tables. The we can say fact table is the center table of the whole all the star schema, which stores the transactional data. Like in a university database, that the fact table stores like the student enrollments, grades, or their IDs and etc. A fact table is generally surrounded by many dimension tables corresponding to it, having relations like having foreign keys and the primary key relationship such type. So what is a dimension table? A dimension table is nothing but it contains the attributes like the descriptive informations, like such as the student details, the name, their course name, and the faculty name, their corresponding department name. So like these tables, they factually enrich the fact data. Like the fact table provides the quantitative, whereas the dimension tables provide the descriptive. So like when we use this both the so they both make the query analysis easy, and we can get aggregate information. So this simplicity of star schema makes it very ideal for like real heavy operations such as the university, like where a student can enroll, or where a student can take off from the course. So like we need like really heavy operations, like we need fast information. Like suppose a student is inquiring about his course or his department or his faculty name or such. So like this star schema is very is ideal for that, and like for efficient querying. So let's unlock the insights in university database. So why does a university database matters? Like see, a university database, it provides a centralized source of truth for institutional data. So like all of the institutions data at one place, and which can be accessed easily. So like which enables us to perform certain decisions on the student performance, their course offerings, the faculties allocations, their departments, and their credits. Uh, it also improves to streamline the data management across departments, reducing the redundancy and enhancing collaboration. So enhance student experience. So this supports the personalized services such as the advising, leading to improved student outcomes like better retention rates. So with all information at one place, we can access it. We can access it very fastly, and we can get certain services like such as the advising and leading. So which can lead to the improved student outcomes. So what is the benefit of a star schema in using in university database? So like this offers a concise structure for easily querying for such a large database. This will offer a concise structure which can be easily analyzed, and the optimized data retrieval with denormalized tables and indexing. As star schema offers a denormalized tables, the the data retrieval is very easy, and which can provide timely insights for decision making. So this can create an initiative dashboards and reports for better understanding. So we also like the Power BI dashboards like which have all the reports and all the analysis of a particular data set. So this schema will help for such creative dashboards, and which can be visually appealing, and which can be visually uh, seen by anyone. So, in context, a university database, a star schema, organizes data into the fact tables like enrollments, and dimension tables such as the students. So, like as I said earlier, this design allows for fast and efficient querying. Like here's a given example. A star schema can reveal student enrollment patterns by department, course, and semesters, allowing university to optimize resource and improve student satisfaction. So let's say that a particular group of students which are enrolling into a department or a course in a particular semester, or derolling from a particular course or a semester. So this can help the university to analyze the particular patterns, like the reasons for their leaving or their enrolling, and which can let the university allow to optimize their resources and improve the student satisfaction. So by using this star schema, the institutions can unlock valuable insights, make data-driven decisions, and enhance the quality of education through better resource allocation and student management. So this is our fact table, which contains the enrollment ID, student ID, course ID, professor ID, department ID, semester ID, enrollment date, grade, and course fee. So the enrollment ID here is a data type of integer, which is nothing but a unique ID given for each enrollment record. And student ID is also an integer data type, which references the student enrolling in a particular course, like an unique ID given to each student. Course ID is an unique course ID given to which like a particular many number of students enroll in a particular course. So each course is given an ID. Same for the professor ID, references the professor teaching the course, like which professor is going to teach a particular course. The department ID, like it references the department offering the course. Like the semester ID references the semester during which the course is taken. Enrollment date when the student enrolled in the course. The grade end by the student for the course. So course fee is nothing but the fee charged for the course. So the fact enrollment table here is the core of this whole schema. Like this records the student enrollments by linking it to the dimension tables like via the student ID, the course ID, and the professor ID and the semester ID. So it tracks key data like the grades and course, which plays a key role while analyzing, while an, uh, while analyzing the students' performance and their course participation across semesters. And coming to the dimension tables, For our database, we are taking 5 dimension tables, like which is storing different context for the fact table. And let's start with the dimension. Let's start with the student table. It has simple 6 columns: the student ID, name, date of birth, gender, address, and contact number. So, like I said earlier, ID is the representing each student. Student name is the full name of the student, and date of use of data type date, which is the student's date of birth. Gender is the gender of the student, and address is the residential address of the corresponding student. Contact number is the student's phone number. And the next dimension table is the course. So, like this dimension table provides the detailed information about the courses offered at the university. Like each course has a unique course ID, as we seen earlier. See, uh, so which will be reference to the other tables in the fact table for enrollments. So this table, the course table has 4 columns: the course ID, the course name, credits, and the course type. So, like the course ID is, as said earlier, it is the unique ID referencing each course, and the course name is the name of the course. Credits is the number of credits the course offers, as we have, uh, this course code, like offers 3 credits, and this course code offers like 4 credits, such as. And course type, like specifies like is this course mandatory or elective. So, like this table here is will help us understand the academic offerings of the institution, like about what a student is going to learn, and what will be his academic offerings given by the institution. And next dimension table is the professor. Like this contains information about the professors or the faculty that teaching the courses. Like each professor each faculty is given an unique ID, and the name is the name of the professor. Email is the email address of that professor. This can be a mode of contact by the university or by the or for the students. The professor specialization, like this tells about the professor's field of expertise. Like one faculty is an expertise in a field of AI, while other may be in a field of some other mechanical or civil. So this contradicts that. Next dimension table is the department dimension table. So this table here records details about all the academic departments within the university. So, like this has 3 simple columns: the department ID, name, and department head. Like department ID, like each department has a department head, right? So this unique ID will represent that each department. The department name will tell about the name of the department, and the department head, oh sorry, department head will tell about the name of the department head. Department ID will uh, is an unique ID given to an department. The next dimension table is a semester dimension table. So this table here tracks the academic semesters during which the courses are taken. So each semester has unique semester ID, and as you know, the semester name, like the start date and the end date, like when the semester is going to start, like in the June of 2024 or something. So, so far we have seen about the fact tables and the dimension tables of our star schema. So this is the visual, this is the star schema that we are talking about. This is a fact table, and these are the 5 dimension tables that we have talked so far. The star schema for the university database is designed to optimize the analysis of student enrollments, course performance, and faculty contributions. At the center of this schema is the fact table, which captures the transactional data such as the student enrollments, grades, and course fees. So, surrounding this fact table is the dimension tables, which contains information about the descriptive information about student courses, professors, semesters, and departments. Let's have a look at some queries. So, to understand, to have a better, clear understanding, let's have this query to get the average grade for each course. So, like This query calculates the average grade that student received in each course. See, like we can take the columns as the fact enrollment column and the course and the dim course like the dimension table course. So this query pulls data from the fact enrollment table, which contains the student enrollment and the grades. See here the grades and student enrollment, and the dim course table, which has the information of the course, of course. Like we are using a join statement here to join the both tables on based on the course ID. As course ID is common in these both tables, we are going to join the tables based on that, and we are using a group by which uh, which which groups the results by the course name, so that the average function can compute average grade for each course individually. So there are three courses. Let's take that there are three courses, so that the average for each course will be given separately. Let's have a look at another query. uh, let's count how many students are enrolled in each department. So this query counts how many students are enrolled in courses offered by each department. So for this, we are using the fact enrollment table and the course detail and the course dimension table and the department dimension table. For We are using which tables for, because we need fact enrollment table for the enrollment for the enrollments, and the course for the course details, and the department for the department information. So what we are going to do is that we are going to join the fact enrollment table and the dimension table to get the course details, and then we are taking the course, and then we are taking the department using the department ID, which is common, to get the department information. So see here, this we did on for the course course and the course and department, and the other join we did it by using the fact and course. So, and we are using here count. This query, the counter counts the number of unique enrollments, uh, and group by is so we are using group by here to group by each department separately. So query to get the number of courses taught by each professor, how many courses in each professor is teaching is teaching. So so for that, we need information from the fact enrollment table, which tracks the enrollments, and the professor table, which stores all the faculty information. We are going to join those two tables using professor ID, which is a common field in the both of those, and then we are using count distinct, so that we are only counting for each professor, as each professor could teach the same course multiple times across different semesters. So this here ensures that when we are counting for an each course, so that is counted for each professor, not for everyone, and the results are grouped and the results are grouped by professor name to show the so that because name is unique, such as the PID, we can also use that. So for each professor, we are going to get how many courses are they teaching. So this is the query to get the average course fee per semester. So this query here calculates the average fee charged for courses in each semester. We are going to use the fact enrollment table, where the course fees are stored, and the semester table, which tracks about the semester. So we are going to join them based on the semester ID to get the respective semester that we are going to see, and we are going to use our average function to calculate the average course fee, of course, and as usual we are using group by for to get for every semester separately, and this is the query. So far we reached the end of our explanation. So in conclusion, to say in brief, university database star scheme design. So It optimizes data retrieval and and enables faster and more efficient analysis for the institution to get the academic metrics for each student, like their performance for and their enrollments. Like this only not enhances the operational efficiency, but also provides a framework for future growth for the universities so that they can utilize their resources uh, completely and usefully, so which can improve their resource allocation and overall education performances. Thank you. Thank you for giving me this opportunity to express my views on the university database star schema, and I thank my regards to my sir.